everyone, in this video we're going to go through some difficult definite integral questions. What makes them a little bit difficult is that you've got function notation introduced to definite integrals. So it's not just a matter of putting it into your calculator or even just calculating the antiderivative. It does require you to, I guess, think logically about what is happening and actually be familiar with the rules surrounding definite integrals. All right, so I've got a few questions here from the textbook and some from past exams. We basically have to do them all by hand because they're using function notation. So it's really testing your understanding of how to do it. Otherwise, you could easily just do it in your calculator. All right, so let's have a look at this first one. So we've got to find this definite integral, which I'll shade in blue. And if we know that this definite integral is equal to 5. Now, this sort of language kind of makes me think, well, not doesn't make me think, but anyone think that you've got to use what we have in purple to help us find blue. Okay, so you can see they're kind of similar. So you kind of want to turn blue into something that represents purple. All right, so we can see it's kind of there. And out of all the questions we're going to do, this is probably the easier one. They do get a bit harder. All right, so with your definite integrals, you can separate them. So if you have definite integral of multiple functions, you can actually separate them. Now I'm going to take the 2 out the front of that integral, and you will notice that what I have just done is now the same as what we've got in purple. All right, so remember that is our aim. All right, so your first definite integral, because we're not using function notation there, it's just x, we can find the antiderivative of x, which is x squared on 2, and we're going from -1 to 2. And then the purple part in the question, it did tell us that it was equal to 5, so we still have that 2 out the front, and we've got 2 times 5. All right, so just completing your definite integral, you could do that on your calculator if you like, but not too hard to do by hand. So substituting in 2 minus the substitution of 1. Now, if you're -1, sorry. If you're substituting in any negative numbers, it's probably a good idea to do it in brackets, just so you don't make any mistakes. All right, so we get 11.5, and you can just leave it as a mixed number. You don't have to convert it to an improper fraction or a decimal. You can if you want, but usually when we start changing things, that's when we make stupid errors. All right, so moving on to the next one. So again, we're using function notation. The good thing is we're just dealing with f of x, but the main difference is we have these 3 different terminals. So let's have a look at all 3 of them on a number line. So I'm effectively going from 0 to 5. Might do my number line in black. So there's our number line. And I just like a number line because it kind of shows what's happening. But when you start doing a lot of questions like this, you will get used to the type of wording used. All right, so let's have a look at the blue one first. So that whole section. So remember, I'm not doing the area under a curve. These are just the signed areas. So that is equal to 1. And for my green, oops, let's just put 1 on. So I've got to do that. There's 1. Not to scale, but who cares? All right, what am I doing? Green highlighter. All right, so this little section here is equal to -2. Now, it doesn't matter that it's a negative because it's just a signed area. And I want this purple section. I want to go from 1 to 5. So I want this whole section here. So you'll notice that purple is basically the blue section minus the green section. So it's 1 minus, so 1 being the blue, minus the green, which is -2. And that gives you 1 plus 2, which is 3. All right, so just thinking it in terms of a number line can help you sometimes visualize it a bit easier. Questions like that do appear on exam questions, usually as multiple choice. And we're going to do some multiple choice in a sec. All right, so here we've got function notation. Again, my terminals are different, different function notation. We've got some transformations there with the 3x plus 1, which makes things a little bit trickier. You can treat ones like this with transformations, but I'm not going to. Before I make a start, let's just have a look at the relationship between the antiderivative and the derivative. So usually we use capital F. Actually, I'm going to use G because in your textbook they use G, but other textbooks use capital F. All right, so g of x is your antiderivative. So it's your antiderivative. All right, so antiderivative of f of x, all right, which you can clearly see. But if we went back the other way, so if I wanted to do the derivative of g of x, I would actually get f of x. So that relationship is going to help us with this question and one of the VCAR questions that we're going to do shortly. All right, so just remembering that your the derivative of your antiderivative gives you back your original function f of x. Okay, so we're going to use that shortly. Let's first have a look at this definite integral here. All right, because we're going to use that. So we've got f of x. So the antiderivative of f of x is just g of x. All right, we don't know what the function is, but I'm using this notation to help us find the antiderivative. All right, and we're going from 1 to 4. So substituting that in, we're going to have g of 4 minus g of 1, and that is equal to 5. So what we have here, let's do it in yellow. I'll underline it in yellow. We're going to use later. All right, so you'll see that pop up later on. And the reason we're going to be referring to this is because it's a little bit different, because we don't have the same terminals. So, and we don't have the same function, so it does make it a little bit difficult. All right, so let's have a look at f of 3 of x. So we're going to use this understanding over here. All right, so we're just going to put a square around that, or a rectangle around that. And I might do this working out in a different color because it is going to be a little bit difficult to initially understand. So our antiderivative, and I'm just not worrying about anything else, just the antiderivative of f of 3x plus 1 dx is equal to g of x. Let me just do 3x plus 1. So let's have a look first of all at finding this this derivative. So we're going to find the derivative of g of 3x plus 1. Now, you had a question like this on your practice SAC and on your actual SAC. So when you're finding the derivative using function notation, all right, and you've got a function inside there, like we do, 3x plus 1, you're just using the chain rule. So we're going to let u equal 3x plus 1. So our function is y equals g of u. du dx is equal to 3, and your derivative dy du is equal to g dash, and then substitute in u, so 3x plus 1. So my derivative is 3 times g dash 3x plus 1. And I'm going to put that back in. Actually, before I do, I can change that g dash to just f, right? Because remember that relationship that I put a square around in green? This relationship here, the derivative of g of x gives you f of x, so I can just replace that back with an f. All right, so let's now substitute that back into a definite integral. So 3 times f of 3x plus 1 dx is equal to, actually where are we going from, 1 to no, we're not going from 1 to 4, from 0 to 1. G of 3x plus 1. Now, what I want to do is just, because we're finding, let me do this in a different color that we haven't used yet. Alright, because we are finding just f of 3x plus 1, and I've got this 3 here. Alright, so we just want this part left. I'm going to take that 3 out the front. Alright, sorry, it's going to take forever to keep writing. Alright, so to treat this like a normal algebraic equation. So if we're multiplying something by 3, the opposite is to divide. Now, when you're dividing, so if we were getting rid of this 3, we could say, alright, let's divide by 3, and then we do the same to the other side. But it's just a lot neater if we're multiplying. I could actually divide by 3. And there'd be nothing wrong with that. But I'm going to be multiplying by 1/3, right? Because 1/3 times 3 is 1, right? So they eliminate. So now I'm just left with what I want. All right, so the question wants us to find this, what I'm drawing now in pink. And I'm going to substitute the 1 and 0 into my antiderivative. So going into G, 3 times 1 is 3 plus 1 is 4. Minus and substituting in the 0. So 3 times 0 is 0 plus 1 is 1. And this is where we need to go back to the start. Remember what I highlighted in yellow or underlined in yellow. G4 minus G of 1 equals 5. We've got G of 4 minus G of 1. So I can just write here 5. Where's that looking? Good if the computer wants to cooperate. And we get 5 on 3. So a bit of a tricky one. First of all, let's just recap the relationship between the antiderivative and the derivative. All right, so you might see G being used or capital G or capital F for the antiderivative. So understanding that relationship is really important to understanding this question. And then also finding the derivative using function notation, which is what we did over here. All right, let's move on to a VCAR question. All right, so I can see this is what we're aiming for. No. Yes, sorry. This is what I want, this pink section, this to look like, all right, to be able to solve. All right, so let's just deal with this yellow section. I can separate this definite integral to 2. Now that 2 is, I've just noticed, is oh no, it's not. 2fx, it's not multiplying the 3 as well. Minus, oops, let's do the dx first, minus the antiderivative of 3 dx. All right, so we're just separating that antiderivative. All right, so we've got the 2 times f of x in one definite integral and the 3 in the other definite integral. All right, so this 2 can go out the front, and we can just do that in one go because we don't want to keep writing things. And you'll notice that I now have, so this thing highlighted in pink, we now have the same thing here. So we've got 2 times 5, because remember it said it's equal to 5. And then I can just do the definite integral. So you could do that on your calculator if you wanted to. 2 times 5 is 10, and then substituting, because we're substituting in, and we've got negatives, let's just use brackets. 3 times 3 is 9, minus 3 times 1, which is 3, so it gives us an answer of 4. So not a tricky one, but can be quite confusing just because of the function notation, which is very annoying. You just got to get used to it. All right, and you can see how I haven't used the calculator yet. So it's quite difficult to do these on a calculator. You really need an understanding of what is going on. All right, so reading through this question. So the first part is differentiable function defined for all real x. All right, so this part here is just making nothing really that we have to focus on, I'm pretty sure. So we just know that A is positive, basically, and your function is positive. All right, so I'm going to just highlight that in pink, sorry, and then I'm going to make this try to appear the same. All right, that's my aim. All right, so we've got this 2 out the front multiplying, and I can split this into 2 definite integrals, so I might go ahead and do that. Just make sure that 2 is multiplying each one. All right, so we don't want to forget the 2 with the second definite integral. All right, that second part is nice and easy. Let's do that just to see what it actually is. So we're going from 0 to 5a. Forgot about that. All right, so 2 times 3x is your antiderivative, 5a, 0. So 3 times 5a, 15a, so we've got 30a. Now, at this point, I could say, well, it's going to be D or E. All right, because I've already got that 30a and I'm going to be adding it to something. All right, so again, we're going to use the relationship between the antiderivative and derivative to deal with this, this first antiderivative. All right, so we've got the antiderivative, and I'm just forgetting about the 2 for a sec, so I'm just showing you the relationship. So that is equal to an antiderivative. Sorry, I should do x on 5. That's our antiderivative. So let's focus on the derivative of the antiderivative. So we're going to let u equal x on 5. So y is equal to g of u. So just performing the chain rule. So the derivative of x on 5 is just 1/5, and then dy dx, the derivative of g dash u is, sorry, g of u is g dash u. And remember, g dash is the same as f, so just substituting in x on 5. So our antiderivative is 1/5 f x on 5. All right, so we can just substitute that in. All right, so 1/5 f of x on 5 is equal to g of x on 5. All right, so just like before, let's just do 0 to 5a. All right, I'm going to take that 1/5 out the front. So let's just do it 1/5. And then to get rid of that, I'm going to be multiplying it by 5. Sorry, I just had to check something. So whatever I do to the left side, I have to do to the right side. So we're cancelling that out. And we're now finding what we want, the antiderivative of x on 5. I've noticed I've forgotten the dx in the previous question, but that's all right. So 5, oops, weird 5, substituting in 5a and 0. So we've got g of 5a on 5, and I'm already noticing something which is pretty cool. And then g of 0. So we've got 5 times g of a minus g of 0. Now, just going back here, this pink section, all right, so our antiderivative is g of x, whoops, and a, oops, sorry, I keep making mistakes, I'm rushing, 0 to a, substituting them in, we get g of a minus g of 0. All right, so a bit all over the place there. So this is equal to a, and that yellow part we just had here. And I feel like I've forgotten that too somewhere along the line. Oh my gosh, silly me. So the 2 should have been here as well. So that 5 should be a 10. Sorry. And then g of a minus g of 0 is a. So our answer is 10a. Oh my god, I'm all over the place. And then don't forget this plus 30a that we did before. What a question. And I probably haven't explained that very well. Yeah. 40a. I forgot to add them together. I was looking for 10a plus 30a in the choices. I was like, yeah, they're like terms. You can add them together. I mean, I was all over the place with that question. Maybe if you're redoing it, maybe do your setting out a little bit easier, better, clearer, I'm sorry. But again, just thinking about the relationship between your derivative and your antiderivative. All right, and that's going to help you answer questions like this. If you couldn't approach this one, like if you thought, oh my gosh, I have no idea, I think you should at least be able to get that 30a by separating that definite integral, and that kind of may help you decide, you know, instead of having a 25% chance, because they're now out of 4 choices, A, B, C, or D, you've now got a 50% chance. So 40A or 50A. All right.